All right, hello. This is section 3.6, solving quadratics equations. Now, we've already solved quadratics in the traditional sense. We've solved them by factoring. That's a terrible, that says factoring. Sorry, I'll print. Completing the square roots method. That's after we completed the square. We got it down to like a perfect square, and then we took the square root of both sides. And then we did quadratic formula. So now we're kind of getting into like the applications. Applications is a fancy way to say the word problems. Now this kind of scares people almost as much as fractions, but don't let it. So it's the fun part. Like now that you know how to solve it, now this is like, this is why I solve it this way, or when I do. All right, so math 1, we had Carlos and Clarita. Remember them? But don't be scared. Carlos is designing a garden. So obviously a garden in this particular problem is going to be a rectangle. Just to reiterate a rectangle, you've got the length and the width. The perimeter is the distance around, so the perimeter is going to be twice the length plus twice the width. And the area is length times width. So that's any general rectangle, just to recall. So this length of this particular garden needs to be 8 feet longer than it is wide. So let's pick that apart. The length is 8 longer than it is wide. If Carlos has enough potting soil for a garden, 48 square feet in area. Here's that quadratic. Okay, so we're going to use this guy. What dimensions, that's the length and the width, fit this rectangle? So if the area is length times width, so the area of this rectangle is going to be length 8 plus W. I'm just going to rewrite that using the commutative property and put the W first. The width plus 8, because you can add in any order. So the length times the width is equal to the area. Well, the area had to be 48. So this setup, and if it bugs you that 48's on the left, you can do what's called the symmetric property and reverse this. So we're going to substitute 48 here. So we're going to rewrite this. W times W plus 8 equals 48. So that's your setup. That's the key. Sometimes I'll have kids say that, oh, I get these word problems, I just don't know how to set them up. Well, that's the battle. It's like having kids when you're trying to get out the door for work. That's not half the battle. That is the battle. So, little tidbit there. So that's your setup. You're just going to substitute your area and your dimensions for length and for width. And then, like if I just gave you this problem, you'd say, oh, Mrs. Buck, that's really easy. So once you're at the setup, now you know how to solve. So we're going to distribute the W. W squared plus 8W. Now this is equal to 48, but let's recall, to solve a quadratic, it must equal 0. Can I abbreviate quadratic? Because I'm going to run out of space, must equal 0. Okay, so I don't know if that was quite emphasized as much last section. So I'm going to kick this over the fence, subtract 48, set it equal to 0. So to solve a quadratic, it must equal 0. Huge. Let's even write it like super big. Huge. Haha, that's a joke because it's really tiny. So this is going to be solved now by either factoring, completing the square roots method, or quadratic formula. Now, if it's factorable and that's easy for you, then go ahead and factor. So in this case, factors of negative 48 that add up to 8 You've got to think of all your factors of negative 48. Now, this is a trick I haven't necessarily shown you yet. On your graphing calculator, if you're stuck with factors, if you just say it's negative, how did we do that? X squared equals 48. X squared minus 48. 8 minus W. I'm trying to think what Mr. Schweizer used to do. I'll have to think of his trick on the table. But anyways, you're trying to think of factors of negative 48 that add up to 8. So 1 and 48, I just go in order. Let me get that out of the way. 1 and 48, 2 and 24, 3 and 16, 4. Like I just go in order, especially when it's a relatively large number. 4 times 12, well, there's our winner. So once you come across your winner, then you can do that. So 12 minus 4 is positive 8. 12 times negative 4 is going to be negative 48. So here comes my factors. W minus 4, W plus 12 equals 0. Set each one equal to 0. All right. Uh-oh. Now, we're thinking of a real life problem. Last sections, you're done because you're like, la, 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 those are the two solutions. But now, we have like a real life problem here. So we can't have a negative width. That doesn't even make sense. The rectangle wouldn't exist. So the width is 4. And then to get the length, we're going to plug that back in. Let me get my handy dandy color here. So the question was, what dimensions fit this rectangle? So the dimensions are 4 feet by 8 feet. How did I get 8 feet? 8, oh, jeepers creepers, 12 feet. How did I flake out? Just like that. All right. White out, white out, white out. Well, I guess I didn't make that much of an error. I caught it right away. But sometimes that bugs me. Uh-oh, look what happened to my white out kids. Uh-oh. 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 I don't know. Maybe I can't use my white out. Let me do a practice run here. Whee! Whee! Oh, I don't think it's going to come back to life. It's all very sad. All very sad. Nope. Better not make another mistake. I caught that one earlier enough, but oh, that's not budging. Weird. Look how much tape is left too. I'll have to try to figure out how to fix that. Figure out how to fix that. 379 gone. Ugh. All right, I digress. All right, how did I get 12 feet? I plugged the length back in. So if the width is 4, you're going to plug that back in right here. 8 plus 4 is 12. All right. So every problem doesn't take, whatever this is, 8 minutes. I'm just kind of going slow to explain that. So I'll kind of kick it up a little bit. All right, Clarita's garden needs to be 13 feet longer than it is wide with an area of 48. And if you want to pause the video right now, you can to give it a shot because it's obviously going to be similar. Not the same, but similar. So Clarita's garden needs to be 13 feet longer than it is wide with an area of 48. What dimensions fit hers? So you can see that it's going to be very similar. So let's say area's length times width. 48 is equal to 13 plus W times W. So this bugs me because I like the whatchajigs to be in front, the variables in front. So this is, when I flip this, that's called the commutative property. I'm not changing the value. When I put this W in front, that's also called the commutative property of multiplication. Remember, 5th, 6th grade is probably coming back at you. And then when I subtract 48, then I just set that equal to 0. So this is, again, what Mr. Schweizer used to call jumping the fence to solve it. All right, so I've got W squared plus 13W minus 48 equals 0. So as long as I already have these factors up here in the upstairs, you can see, I'll circle this in green, that 3 and 16 are going to be my winners here. Also, one of them has to be negative. So let's make the 3 negative, because 16 minus 3 is positive 13, and the 16 positive. Set each one equal to 0. This one gets the boot, because you cannot have a negative length in real life, right? Oh, jeepers, I'm off the grid, sorry. So the width is 3 feet. The length is 13 plus 3 is 16 feet. All right. Now, some kiddos are like, I can just do that in my head, 3 and 16, and know that I know, but when we start things out easy, you know, we try to find the pattern, but, you know, when we expand that pattern to gigantor numbers that you can't do in your head, now you've got the process. All right, we know the 3 methods for solving quadratic equations. So we know that they are factoring, completing the square roots method, and quadratic formula. Do you want me to write that out? I will write that out. Quadratic formula. Boy, Sunday night, I'm struggling here. Solve each problem using all 3 methods if the method is reasonable. Okay, so this one we just solved upstairs by graphing. So, oh my gosh, I just told you that I was struggling. So I'm going to say factoring, see above. See number 1. All right, so the second way is completing the square roots method. So if, you know, your partner did it factoring and you're like, I love completing the square, and some of my students do, because all you do is take half of 4 squared is 16 minus 48 minus 16 equals 0. So we've been completing the square for a while. This does that. So now you might need your calc. Is this off the grid? Second clear, 48 and 16. Now they're both negative, so I just do minus 64 because, I mean, you could do negative 48 minus 16 before someone calls me out on that. I just knew that that would be a negative sum. Bring over the 64. X plus 4 squared equals 64. Square root. X plus 4 equals plus minus 8. X equals negative 4 plus minus 8. Don't leave it like that. Negative 4 plus 8 is 4. Negative 4 minus 8 is negative 12. Gets the boot. And then you follow that same process again. 4 feet, 4 plus 8 is 12. All right, and then just to recap quadratic formula. Now some of you are like, this is way faster, Mrs. Buck. Again, it is if that's easy for you. If that's easy for you, do it that way. If you have a quadratic formula program, then do it that way. Or this works every single solitary time. Factoring only works with rationals and when it's factorable. Okay, this will work every time. This will work every time. It's not always the best method. If this is odd, it gets messy with fractions. But if you're an expert at alpha F1, then fractions are not a big deal. So A is 1, B is 8, C is negative 48. X equals opposite of B plus or minus square root of B squared minus 4AC all over 2 times A. That's Notre Dame. I did not go to Notre Dame. I went to the U of I, University of Illinois in Urbana-Champaign. A terrific 4+ years. What is the square root of 256? 16. Which I only had you memorize through 15. Maybe you guys are getting good at that. So negative 8 plus 16 over 2. negative 8 minus 16 over 2. Now, we know ahead of time this is rational. See, this is going to bug me that that's there. If my whiteout was working, I could X that out. I don't know why I'm talking like Kermit the Frog here, but oh well. It's gone. It's gone, Buck. Give it up. So, negative 8 plus 16, you get an answer, then divide by 2. So you get 4, and negative 8 minus 16, get an answer, divide by 2, negative 12, gets the boot, same process. All right, so that was a bit of a review, depending on if I put this in an Edpuzzle or in a YouTube. You might be like, yay. So that is that. Right now I'm at 15 minutes. So what's on the other side? I think I'm gonna let you do this one. So the biggest thing here that you might not have understood last week is to solve a quadratic by any method, by factoring square root or quadratic formula, it must be set equal to 0. So we already solved this one by factoring, okay? Just for time's sake, I'm not sure if I'm going to put this in an Edpuzzle, like I said, or a YouTube. I would pause it now if you want. Make sure you get the same answers. But I just want you to think, one that I haven't done a whole lot yet is graphing. Okay, if you graph this, y equals, clear, x squared plus 13x minus 48. Now, last year I did a lot of graphing because I would hand out graphing calculators or force you to walk down the hallway and rent one for the school year. But alas, we're not there. So I can't really force the issue. You've got one on Desmos you can use. There is a download on your Chromebook. If you didn't get that email this summer, you do have a Chromebook app that I will try to hunt down for you. That doesn't look like a parabola. X squared plus 13x minus 48 because the y-intercept is down there. So right now, if I hit zoom 6, it puts me in a 10 by 10. Here's a little bit of a conversation about graphing. I know this is a parabola because it's a quadratic, and a lot of students see this as a line. So you have to change your window. So typically that y-intercept is going to be a giveaway. So the y-intercept is negative 48. So I'm going to change my window to like negative 25, 25 on the x-axis, and then negative 50 and 50 on the y-axis. So we're starting to see the parabola a little bit better. But if I want to see the vertex, like right now, it's way over here, and it's right there. And I know that this is negative 48, but the vertex is still here. So it doesn't matter what you set your window at as long as you can see it. So let's do our y min like negative 100. And then I can see it, and it's just a little bit prettier. Now, to find this, we could see it on the table. Like x-intercepts, if they're rational, you can see this on the table. So second table, that's where the y value is 0. So this is 3, 0. And again, I know some of you are like, we already did this. I know. But if you didn't, the other one is going to be hard to find because you could see this is getting bigger, bigger, bigger. Oh, I'm going positive. Duh. Come on, Buck. That wasn't smart. So I'm going this way. But what I was saying was, I know we already solved it, but again, if you didn't know it and you are like your graphing calculator, those are the intercepts as well. But in the real life situation, this one's going to get the boot. The dimensions are going to be 3 and 6. What was it? 13. Oh, this should be x. Okay. What else do I want to tell you about the graphing calculator, though? You can play around with this. It's kind of fun. On Desmos, you could play around with it, too. But I just want you to always remember a quadratic is a parabola. So you can use not only the 3 algebraic methods, but a graphing method. So we've got, oh, this is going off. Why? I don't know if this video is like blacking out on me, but it is. So these 3, factoring, boy, now I'm really abbreviating, square roots method, completing the square, and quadratic formula. These are all algebraic ways to solve. Algebraic. But the 4th way is always your graphing calculator. Okay. So I'll try to kind of keep playing with this. Math 3, Math 4, I use your calculator a lot. I don't know. It's just, we'll do our best, right? In this remote setting. So use all 3 methods of solving to determine the dimensions of a garden that will be 16 square foot in area and a length that is 6 feet longer than it is wide. So I'm going to say x squared. I don't want to say x squared. I want to say, let's set this up. The dimensions that are 16 feet, so 16 equals a length that is 6 feet longer than it is wide. So w squared plus 6w minus 16 equals 0. Factors of negative 16, you got 1 and 16, 2 and 8, 3, 4, and 4. Okay, so obviously 2 and 8 are winners if you're factoring. The 2 will be negative. W minus 2, w plus 8 equals 0. W is 2, W is negative 8. Gets the boot, because in real life you can't have a negative dimension. So this garden is 2 feet by 2 plus 6, 8 feet. Okay. What else is use all 3 methods to determine the dimensions. That will be that. I don't want to do that because my video is already at 22 minutes. So determine which 2 best methods allow you to solve this. So this one is x squared. To me, right here, I would solve this by completing the square. It's just kind of, I mean, you cannot solve this by, well, the factoring 4 and 4 won't work, 8 and 2, because one of them has to be negative. That's not going to work. That's why 8 and 2 won't work. So this is not factorable. So you either have to do completing the square or quadratic formula because it's not factorable. Don't say there's no solution. So back last module I said don't say there's no solution because when we stick an equal sign in there we actually can solve it. It's just not going to be by factoring. So time flies. All right, so let me do completing the square. X squared plus 10x, half of 10 is 5, squared is 25, minus 16 minus 25 equals 0. X plus 5 squared minus 41 equals 0. X plus 5 squared equals 41. Square root. X plus 5 equals plus minus square root. X equals negative 5 plus minus square root of 41. Now notice, this isn't a real life example anymore. If you were making a garden and you were like, oh, let's make the sides negative 5 plus and minus square root of 41. Like, that wouldn't really make sense. People ballpark it. Now, it might be that if you didn't measure it exactly, but that's how, that means your dimensions would be about 1.40 feet by, let's see, negative 5 minus second square root of 41. There's the one that gets the boot. So you'd plug that back in to whatever the other dimension was. I think I just made this up. But when they're irrational, remember that word? Irrational. They're going to be ugly decimals that are non-repeating, non-terminating. So most things in real life are going to be rational that you make, like the dimensions of a garden. Now, if a ball is bouncing and you're trying to determine the height or when it lands, that's most likely going to be irrational. See, these are all parabolas. Isn't that fun? Or if you're diving on a diving board, whee! and you go boing, and I say, when are you going to hit the water? You're probably not going to hit it at exactly 2 seconds or 3 seconds or something rational. You're probably going to hit it at like an irrational. That's why the Olympics has to go out to like 300,000ths of a decimal when they time it. Okay, and then just quadratic formula. I'm already at 25 minutes, but what the heck. X equals opposite of b plus or minus square root of b squared minus 4ac all over 2 times a. Love football. Do you guys love football? So this is 100 minus 4 times negative 16 is 164 over 2. Now, I usually start with 4, see what that gets under the radical. Ding, 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 ding. And then I haven't really harped on this, but we're going to factor out a 2, negative 5 plus or minus root 41 over 2. Whee, gets to cancel. Same answer. All right. That was messy. Love you. See you soon. Bye. All right. Turn this puppy. Sorry, 26 minutes. Not bad.